Hey guys, welcome back to Learning Kotlin Live episode 58. And today we're going to move on our coroutine journey. Shared mutable state and concurrency. So we covered coroutine context and dispatchers last time, and we learned about how coroutine is you can assign dispatcher and name and context to coroutine. Well, I am not quite sure what's the difference between context um, and name at this moment. But anyway, my lesson learned from that chapter was mostly about how coroutine can be built and dispatched easily on different threads, and there is a hierarchy of coroutine and subcoroutines and how these property delegates, and we also talk about the life cycle of coroutine, and um, we can attach that concept, apply that concept to objects with life cycle, like in a GUI, in a GUI based system. There is a main thread, and there are something that is there are different life cycle of different threads, and that's something we can apply it to. So that's what we have covered in episode 56, I believe. Yep. And today we're going to move on to this chapter, and this chapter is titled Exception Handling. The section covers exception handling and cancellation on exceptions. Cancellation on exceptions? Huh? We already know that cancelled coroutine throws cancellation exception in suspension points, and that it is ignored by coroutine machine. But what happens if an exception is thrown during cancellation or multiple children of the same coroutine throw an exception? Okay, that's complicated. Exception propagation. Coroutine builders come in two flavors: propagating exceptions automatically by launch, but I don't know what this actually means, or exposing them to users async and produce. I know async and launch. So this one is propagating exceptions automatically, and this one is exposing them to users. The former treat exceptions as unhandled, just like uncaught exception handler. So that means these exception would be propagated. While the latter are relying on the user to consume the final exception. We haven't talked about the channel section, so yeah, we're not going to cover that now as well, but we know await. So let's see. So if we create a coroutine and global scope, where is it? Here. If we have a job here, and if we throw an index out of bound exception, it will be printed to the exception handler. So yep, there is going to be we're going to have a default exception handler because it is launched. So the coroutine would probably move on, I guess. There's a job and a deferred, and job is joined and deferred is await of deferred is caught. So this is global scope.async. It is using the async rather than the launch building block. So So basically, we're throwing an exception from launch, and the exception is directly handled by the default. I don't know where is it, but some uncaught exception handler. And so everything is not um, the parent of this. Is this the parent? I don't think so, because it's launched in the global scope, so it's actually not the parent of it anymore. So I actually wonder what happened if we have code after this throw. I think it's still stopping, just that the main thread doesn't crash. And on the other hand, if this arithmetic exception is thrown, then we need to manually catch it, because in the block where we call await. So this is something we just I just asked about. So in the context element, there is a coroutine exception handler. So yeah, we can register coroutine exception handler via service loader. Where is it? I don't see it. And again, it's just talking about global exception handler is similar to thread.default uncaught exception handler, which is used when no more specific handlers are registered. And on Android, uncaught exception pre-handler is installed as a global coroutine exception handler. So we already have an uncaught exception pre-handler here. Coroutine exception handler is invoked only on exceptions which are not expected to be handled by the user. So registering it in a async builder and the like of it has no effect. Huh? What? What? What does that mean? I don't quite get what does that mean. Yeah, the deferred is not called, so that's why we're not seeing that arithmetic exception. But because this is a launch, so it is directly called. And although this is async, because await is not called, so we're not catching that. We're not catching that exception, even though this throw arithmetic exception is run, is executed, because there is no laziness here. That's a little bit hard to remember. A little bit not that intuitive, I would say. Okay, cancellation and exceptions. Cancellation is tightly bound with exceptions. Coroutine internally use cancellation exception for cancellation. These exceptions are ignored by all handlers, so they could be used only as the source of additional debug information. That means that, yeah, it actually talked about it directly. A catch block is not going to catch that cancellation exception. It's just for debugging. When a coroutine is cancelled using job.cancel without a cause, it terminates, but it does not cancel its parent. Canceling without cause is a mechanism for parent to cancel its child without canceling itself. So this is tricky. If you cancel a job without a child, without a cause, then its parent will not be cancelled. But I believe it means that if there is a cause, then the parent will be cancelled. So let's see. We have a job which is again probably launch blocking, run blocking, and there's a blocking dispatcher. It's on a blocking dispatcher, and later this is on a blocking dispatcher as well. So this yield gives the give this coroutine a try, and it delays for super long, and for I don't know why, but probably the finally is can oh, okay. There's a try and a finally, and this finally will happen after this child is cancelled. So basically, I think the flow is this coroutine is scheduled, and then because of yielding, this delay is executed, and because of delay, this print loan is printed, and child is cancelled and joined, and so finally is executed, and parent, but we with this yield and print loan, we can see that parent is not cancelled. So basically, canceling child is cancelled, and parent is not cancelled. If a coroutine encounters exception other than a cancellation exception, it cancels its parent with that exception. So the parent is cancelled instead. This behavior cannot be overridden and is used to provide stable coroutine hierarchies of structured concurrency, again, which do not depend on coroutine exception handler implementation. The original exception is handled by the parent when all its children terminate. So there's a delegation. When a child there's an exception in a child, its parent would receive that and cancel all the children, I guess. Yep. There's a typo in this document. Yep, I'm forking. What? Why? This is also a reason why. Where is this? Where's this block? I think this is missing. I think this is, let's check it with, what's that? Grammarly? I think this is not acceptable, right? intricate text. I think in dun, 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 dun. Oh, it's still there, but there is no plagiarism. Yeah, I think there's a okay, that's called plagiarism. What? What? Plagiarism? No, that's not something I want to check. Then that's don't. If anyone is anyone is native English speaker and is pretty sure that this this line is weird, please help it file an issue for me. So this is also a reason why Nix examples is always installed to a coroutine that is created in global scope. It does not make sense to install an exception handler to a coroutine that is launched in the scope of the main round blocking, since the main coroutine is going to be and always cancelled when its child completes with exception despite the installed handler. Okay. So the main coroutine is going to be always cancelled because it's around blocking, because it's not dispatched on another thread. So fail handler, coroutine exception handler, unused parameter exception, print load, caught exception. Oh, that's a coroutine exception handler definition. Bail job global scope launch. If you launch something, you try delay and launch delay and there's a child. Oh, there's a global scope and there are two child in that global scope. And the first one, well, what does this with context non-cancelable mean? So children are cancelled. Okay, so this is about how the exception is dealt last. Let's see. So there's a arithmetic exceptions run. So basically, there's a delay. Here's a delay, and so the second child throws an exception first happens, and it throws an arithmetic exception. Then finally, because the first global scope, which is the parent coroutine, would need to handle this. Would first cancel its child, which is this child, and this child receives that cancellation exception. So the finally block is run, and children are cancelled, blah blah and blah blah, and finally the caught exception is caught. That's my guess. Yep. So yep, second children throws an exception, and children are cancelled. The first child finish and caught Java, and the caught exception is handled last. Exception aggregation. What happens if multiple children of a coroutine throw an exception? The general rule is the first exception wins, so yep, of course. So the first run exception is exposed to the handler, but that may cause lost exceptions. Yes. For example, if coroutine throws an exception in its finally block, so additional exceptions are suppressed. So this is about if this is run and this is run, this comes later, so this would be handled later. Only IO exception would happen here. Oh, but there is also with suppressed Java long arithmetic exception. Really? Oh, because every child is cancelled. Every child is cancelled, so the exceptions are zipped into one exception, which the first exception is the representative exception, and the remaining items are zipped into the exception dot suppressed. Let's see if that is true. Let's try this. Runtime exception. Oh, there's no runtime exception, or maybe this. And yes, runtime exception and arithmetic exception are both suppressed. So here the additional notes claims that one of the solution would have been to report each exception separately, but then defer.await should have had the same mechanism to avoid behavior inconsistency, and this would cause implementation details of a coroutine, which is whether it had delegate parts or not, to leak to its exception handler. So this is just a comment around why coroutine, the designer of coroutine, have decided to not report each exception separately. And the main reason is because of this deferred.await, which I am not familiar with. This above code will probably only in JDK 7 plus. Okay, I don't care about JDK 6 plus, 6 minus. Note this mechanism currently works again. Limitation on JS and native is temporarily and will be fixed in the future. Okay, so it's just temporarily. So cancellation exception are transparent and unwrapped by default. What does that mean? What does that mean? Oh, so there's a cancellation exception here. And we tried to throw cancellation exception, but actually we get the IO exception instead, because that's why we said that cancellation exception cannot be catched. Actually it can be catched, but only what we will see in this block is actually let's print it out actually. So wait, what happened? Oh, okay, here it is. We see a job cancellation exception here, but actually when we thrown it, Oh. How? What if we don't throw it? Okay. And what if we don't throw the IO exception and only throw the cancellation? Then this will not be cancelled, right? I don't think I'm not sure if this works. Nothing happened. Okay. Okay. So I think this is no, it's not ignored because wait, okay, wait. And rethrowing, and oh, then we caught it. We caught it actually. Oh no. Yep. So the outer coroutine exception handler always ignore the cancelled exception, the cancellation exception, even if it is thrown. I think this is what that means. Supervision. As we have studied before, cancellation is a bidirectional relationship propagating through the whole coroutine's hierarchy. Yes, because the parent will first cancel the if there's an exception in a child in one of the children, then the parent is cancelled, and when the parent is cancelled, the child of the children of the parent is cancelled as well. So that's what this part means. A good example of such a requirement is a UI component with the job defined in its scope. If any of the UI's child tests have failed, it is not always necessary to cancel the whole UI component. But if UI component is destroyed and its job is cancelled, then it is necessary to fail all child jobs as their results are no longer required. Another example is a server process that spawned several children jobs and need to supervise their execution, tracking their failures and restarting just those children jobs that had failed. So this is supervision job. For the later purpose, we can do there is a supervision job which when its children failed, itself would not be cancelled. That's my guess. It is similar to a regular job with the only exception that cancellation is propagated only downwards. It is easy to demonstrate with an example. So which means that if there are first child is failing and first child is cancelled, but second one is still alive because the parent is not cancelled. And if the supervisor itself is cancelled, second child is cancelled because supervisor is cancelled. So yeah, this supervision job is basically for cases that children are prone to be cancelled or interrupted, but when there is one of these that there is one of these children that is abnormal, the parent itself is not cancelled. So let's take a look at the code. So if we have a supervisor job with a name supervisor and with coroutine context plus supervisor, with a scope coroutine context plus supervisor, we have a first child which is failing, and the fail we throw it assertion error, and we don't have handler here, but because this is launched, so it will delegate to the default exception handler. So however, actually that's not quite a sequence. The the parent would get the cancellation of the first child, but it will not cancel the second child. So this is after this, the default exception handler comes in and catches the exception. So first child is failing, and then there's an exception here, and because second child waits for the first child, and after the child is cancelled, it prints first child is cancelled, but second one is still alive, still active. We know this is true because this only happens after the first child stops. So we delay for later again, and later we join the first child and print canceling supervisor, and cancel the supervisor and join the second child, and this is when the second child is cancelled because supervisor is cancelled. Supervision scope. For scope concurrency, supervision scope can be used instead of coroutine scope. Okay, so there are different scopes. For the same purpose, it propagates cancellation only in one direction and cancels all children only if it has failed itself. It also waits for all children before completion, just like coroutine scope does. So it's basically the same. You can just use supervisor scope instead of with coroutine scope, blah blah. We can just use supervisor scope here. Oh, we don't have a playground here. Okay. But basically everything is the same, right? There's a child and yield, and there's a assertion arrow. So child is sleeping and child is cancelled after the assertion arrow is called. Child is sleeping and throw exception from scope, and the exception is the exception is caught, and the child is cancelled, and the arrow is caught by the but why? Wait. Why is it caught? Supervisor scope. Interesting. I am not expecting there's a try catch here. Or I think things can be always try catch or delegated to the default exception handler. Exceptions in supervised coroutines. Another crucial difference between regular and supervisor jobs is exception handling. Every child should handle its exception by itself via exception handling mechanisms. This difference comes from the fact that child's failure is not propagated to the parent. So if there's a supervisor scope, and if something is thrown, the child should have its own handler or the default handler. I don't know if this is removable, but scope is completing. So basically child throws an exception, and then this handler calls it. Child runs an exception. Scope is completed comes first, and these two, and scope is completing comes last after the catch. Where's that catch? Okay, wait, because this assertion arrow is handled by the wait, there's a supervisor scope, and this is itself run blocking. So okay, that makes sense. So this is another coroutine. This is a child coroutine of run blocking, and this is the grandchildren of the run blocking. and this is always first a run because this is a run blocking. If no one else it's going to run till the end, and then there's an exception, and then the caught, and this is another child of the this is the supervisor scope itself. So it is not going to be cancelled because of this exception here. So the print alone is later run. Why is this not first happening? Oh, because there's a suspend point here. And that's all for today. Is there anyone watching? Nope. So that would be the end of today. Bye bye.